Here's a number that will change how you think about moisture problems, okay? 98%. What is that? Well, that's how much of all water vapor movement in buildings happens through air currents. Not through walls, not through vapor diffusion, but through holes and cracks in the house. 98%. Let's break down exactly how moisture moves so you can spot problems before they become disasters. Moisture moves through buildings and homes in three ways. And understanding these pathways is like having X-ray vision during your home inspections. First, with air currents, and this is the big one. Air carries moisture, and air always moves from high pressure to low pressure through whatever path is easiest. Usually that's through holes and cracks in the building envelope. Second one, by diffusion through materials. This is moisture slowly working its way through solid materials. Diffusion, like drywall or wood. Third, by heat transfer. Temperature differences drive moisture movement in ways that might surprise you. So remember that 98% number? Here's why air movement is so critical. It's fast. We're talking several hundred cubic feet of air per minute through building cavities. That is a lot of moisture getting transported very quickly. This is why air sealing is so effective. When you seal those unintended air paths, the gaps around the windows, the holes where the utilities penetrate the walls, the cracks in building envelopes, when you seal those paths, you're stopping 98% of moisture movement right there. Now, for some science that actually matters in the field. Moisture movement follows the second law of thermodynamics, thanks to Rudolf Clausius and Lord Kelvin for figuring this out. Basically, moisture always moves from high concentration to low concentration, from warm areas to cool areas. And so what does this mean for your inspections? Well, in cold climates, moisture wants to move from inside the house to outward, right? Inside warm to outside cold, warm to cold. And in hot climates, it wants to move from outside in. And this affects where you'll find problems during your inspections and what details will matter the most. Those other two pathways, diffusion and heat transfer, are much slower. Building materials significantly slow down moisture diffusion, though they never really stop it completely, right? And insulation, this is really cool, insulation reduces heat transfer, which helps control temperature-driven moisture movement, insulation. So here's the key insight, because air movement, 98%, is so much faster and accounts for so much more moisture transport. Fixing the air leaks gives you the biggest bang for your buck in controlling and managing moisture. Time for some terminology that sounds scarier than it is, right? Psychometrics. Well, that's just the science of measuring the relationship between air temperature and the moisture content. It helps us predict where condensation will form. So here's what you need to know. Warm air holds more moisture than cold air. When warm, moist air hits a cold surface, it can't hold all that moisture anymore. So water condenses out. And that's the dew point, the temperature where water vapor turns into liquid water. Relative humidity tells us how much moisture is in the air compared to how much it could hold at that temperature. So here's a practical example. Air at 68 degrees with 100% relative humidity, okay? It contains about 28% more moisture than the same air at a cooler temperature, 59 degrees, same relative humidity. So what this means for home inspections, when warm, humid air moves to a colder space, like inside a wall cavity in the winter, condensation can happen. That's wet insulation, rotted framing, mold growth, waiting to happen. Here's your takeaway. Control air movement first, because that's where most moisture problems start. Proper insulation helps by controlling temperature differences. Vapor retarders can help control diffusion in the right climates. And when all these systems work together well, they prevent condensation from forming in the walls and in the floors and in the ceilings. But remember, in spaces like attics that are deliberately ventilated, the rules change. So understanding these principles helps you evaluate whether what you're seeing makes sense for that specific situation or not. Every moisture problem you'll encounter in the field comes down to these basic physics principles. Master how moisture moves, and you'll understand why certain details matter and others don't. You'll spot potential problems and explain them clearly to your clients.